In this video, we're going to continue talking about solving equations using the equations menu in wxMaxima. But it turned out that what I wanted to be part 1 was taking too long, so I had to split it into part 1.1 and part 1.2. So this is the beginning of part 1.2. Here we have equation roots of polynomial real. When you use that one, the command that is triggered by using equations roots of polynomial real is this expression real roots. And in this case, we didn't do anything because we already have the solution. For the case for the fifth degree polynomial that we solved earlier, where we found that we have 4 complex solutions, if we use the real roots instead of all roots, and we do shift enter, we get only one result, which is the only real solution that you have for that. Is given in a symbolic format as a fraction. If you do float parenthesis the percentage symbol between the most immediate result before and do shift enter, then you find that that result is equal to 248858, which is what we had found earlier in that in the previous application. Now, equation solve linear system. Okay. If you do that, you will be getting an entry asking you for the number of equations. When you do that, say for example 3, then they give you a space to type the equation. And the case that I'm presenting here, I'm using x1, x2, x3 as the unknowns, and I type these 3 equations. And when you press OK, then you get these results. So you trigger this command called linsolve, which is linear solver. The equations are in brackets, separated by commas, and the unknowns is the second argument of the function, enter in brackets and separated by commas. And when you press shift enter for this case, then you get your results as fractions. If you do float or the previous result, shift enter, then you get your results in decimals. In this case, I have 2 equations with the same, well, let's see, this one and this one have basically the same coefficients for x, y, and z, except that this one is this one. The third one is the first one multiplied by 2. So that means you have 2 parallel planes. There's no solution. In that case, when you try linsolve, it gives you an empty set. There's no solution for that case. And it's in the third case, there are two planes, but there are 3 unknowns. Although I'm only solving for 2 of them, in that case, also there is no solution. In this case, I have 2 equations with 2 unknowns. Linear system. If I use float immediately following the command, then I get the results in floating points. Solve algebraic system. In that case, instead of linear systems, when we trigger that command, which is equations solve algebraic system, then they ask for the number of equations, let's say 2, and they ask you for an entry form where you're going to type the equations. I already typed them for you: x squared plus y squared, x plus 2xy. These are non-linear equations. They are usually called algebraic equations, but they have to be polynomial. You cannot use trigonometric and stuff like here. And so when you do that, you're gonna get this command alg. So let me try this one for you. We'll go equations solve algebraic system with 2 equations, and the equations that we're gonna type are these ones: x squared plus y squared equal 25, x plus 2 times x times y plus y cubed equals 38. And the variables to solve for are x, comma, y. Say OK. And then it gives you a bunch of possible solutions for that. Second example presented right here with 3 equations and 3 unknowns will give me as many solutions as possible. If I want to see this in floating format, do float, and it will give you these sets of results. Equations, eliminate variable. When you use the eliminate variable in here, they're going to ask you the equations. And so, for example, in here I type, this is what I wanted to type in. An equation xy plus c equals 23, x times y minus z times x equals 123. So I have three equations with three unknowns, but I just want to eliminate one of them. And so I'm just going to keep one of them. I eliminate x and y. When you do that, if we do shift enter here, it turns out that the resulting equation with z is that equal to 0. And you can actually solve it for z if you want to by using equation solve, except that I use, let me fix that because I should have put a z here. Now let's go over here again and then repeat this command. Sorry, where are we? Well, it's not working. This is what we're going to do. We're going to go and get the interior of this, selecting, do Control C, delete this, Control V, and this time we did get a horrible long result right there, you can see. And one thing we can do to try to solve that is say float. And still it's giving me a very long result. I'm going to try one more thing here, and that would be to say simplify, complex simplification, rectangular form. For some reason this can kind of give you in complex numbers, but using the polar form, and the rectangular form provides a more reasonable result. And then we can try and even do a float, previous result, and there is the final result that we were looking for. Just the way the Maxima works. Try rectangular form and try float when you get some complicated results like that. Here's another example with a simpler system, linear system, and we're going to eliminate x from those two equations. And then we'll get the equation minus 2 times y. It should be equal to 0. And then you could actually say solve. Select the equation from inside, Control C to copy, Control V to paste, comma, and we're solving for y, Control Enter, or sign enter. One thing is that it keeps jumping or pushing the last result high up, and then you have to scroll down. Now we're going to stop right here because this covers most of the equation solution before we get into the ordinary differential equations, and this way we end up with this part 1 of the equations menu in Maxima.